Another topic, improper integrals involving sines and cosines. Improper in a sense that the limits, the interval of integration contains infinity, and the function also consists of, that means the function involves sine and cosine as well. So consider the improper integral of the form minus infinity to infinity f of x sine ax dx, or integral minus infinity to infinity f of x cosine ax dx, where a is a positive constant. We can evaluate these integrals by the use of residue theory. We can consider the integral from minus r to r f of x e power iota ax dx is equal to integral from minus r to r f of x sine ax dx plus, this is cosine ax dx plus iota times integral from minus r to r f of x sine ax dx. So instead of solving this type of integral or this type of integral, what we do, we will consider this type of integral, and then finding the real part and imaginary part, we can find this or this. If you evaluate this one, the result is decomposed into real and imaginary parts. The real part will give us the value of this integral. The imaginary part will give us the value of this integral. Okay? So with the fact that exponential iota az mod is exponential minus ay, which is bounded for y greater than or equal to 0. What we mean by this? In fact, we will follow the same 8 steps over here. That means at a certain point we have to find the value of the integral over CR f of z e power iota az dz and prove this to be 0. Value of this integral is equal to 0 when r tends to infinity. So that means we have to find the magnitude value of this one. The mod value of this one can be found. What is the mod value of this one? The mod value of this one is nothing but it is, if you put z is equal to x plus iota y, z is equal to x plus iota y, then iota az is iota ax plus this is minus ay. So exponential of this mean exponential of this, the mod of this means mod of this, and this will be this one. Now this exponential minus a is y, we are putting the restriction over the value of a, that is a constant, but this constant is positive. This constant a is taken to be positive. If this is positive, and if y goes to infinity on the positive side, then this is positive, infinity, so e power minus infinity will be 0. This one? Just the mod value of this exponential minus iota a, this mod value, it will remain the same because it is iota ax. What is exponential iota ax? It is cosine ax plus iota sine ax. If you take the mod value, that will be 1. So this is, and this is nothing, because it is always positive, no need of writing magnitude. E power exponential, exponential function is in the real variable is always positive. There is no certain value of y for which it becomes negative. So no need of making the absolute value. It is just this one. Understand or not? Now if this is this one, then when we take y positive greater than or is equal to 0, means we can take the value infinity as well. So this becomes 0. So that means this is bounded. Okay? This is bounded, and why not we are taking y less than 0? We can take y less than 0 as well. If we take y less than 0, this becomes unbounded. But why we are considering y greater than 0? The point is that we are considering the contour which is lying in the upper half plane, not in the lower half plane. In the upper half plane, when we take r tends to infinity, that contour's semicircle will go towards the positive y infinity. Okay, do not go down. So at the most y can approach infinity, and if y can approach infinity, it becomes 0. If we take the lower half, then we will consider y less than or equal to 0. We are not considering that lower half. We are taking only the upper half, and for the upper half, y is greater than or equal to 0. Okay. So we will follow the same 8 step for this particular example as well, to evaluate this type of integral or this type of integral. So we will go for this integral, and after that dividing the real and imaginary part, we can get the results.